All right, as we pick up with our second lesson, actually, today we're going to do rotation. So if you want to update your title page, you have page 1 is exponent rules, 2, 3, 4, and 5, all are regards to translations. Add 6, rotation. We're going to go over the notes. And at the very end, number 7, page 7, it's the second sheet. It's rotations homework, and we'll actually do one to get you started with the homework. All right, as we jump in, rotating shapes around the origin, and we're talking about having a central point. And when I say talking about rotating around an origin, I mean the origin is the very center of the graph. So I'm actually going to be rotating with respect to that point right there, okay? That dot in the center. So imagine like putting your finger on the dot, and then if we go to the left, and this would be against the clock, so this would be considered counterclockwise. And when you think about counterclockwise, that's a long word to write, so it can be abbreviated by simply saying CC. So counterclockwise is CC. So if I go to this direction to the left, and this angle right here is actually makes a 90-degree right angle, this would be a 90-degree counterclockwise, and it would move it from this position in quadrant number 1 to the new flag that we see in quadrant number 2. If we rotated it an even farther, past 90 to another 90 until we get down here to the red looking flag that's in quadrant 3, then we would actually go through 180 degrees. Notice Miss Jessup didn't say 180 degrees clockwise, or she never said counterclockwise either, which leads me to just make note of clockwise is another way to describe it. Clockwise would be abbreviated CW. If you go clockwise, you're going to be going around to the right, much the way the hands of a clock move. If you're counterclockwise, the hands of the clock work backwards, and so you're going around to the left. So counterclockwise is around to the left, clockwise is around to the right. Now, just to finish this up, if we were going to go past 90, past 180, another 90 till we get down here in the corner to the bottom flag, we would be talking about 270 degrees counterclockwise till the flag is in the new position. So today we're talking about turning it, again, keeping our finger right here in the center of the graph. So we would have that central point, and that's the point that we're going to rotate the figure about. So let's just start rotations today. Let's start with a 90-degree rotation. I have an image here, it's black and white, and I have my central point is 0, 0, which is where point A is located. A prime is right at the center of rotation, so for our intents and purposes, that point does not change. So A and A prime are exactly the same. Now I need to move from this position to this position, so we're going to rotate here 90 degrees to that new place from quadrant number 1 to quadrant number 2. And when we do that, the new position of flag is back 3 and up 3. So back 3 is -3 and up 3 is +3. We're going to take note of all of the points on the flag, and then we're going to try to look at the list of points to see a pattern. Okay, up here's the top corner of the flag. It's going to rotate way over here to the opposite corner. C prime, again, it's 90 degrees of rotation, and that would take me 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's backwards 5 is -5, and up 5 is +5. Now we're going to get to D. D is going to go from here to here. So we're going to go from here to here. So D is located over 7 and up 3, but D prime is not quite that far to begin. D prime would take me 1, 2, 3, and then up 1, 2, 3, 4, 5, 6, 7. Left 3, so it's -3, and up 7, +7. Okay, E. E, coming from here, all the way rotating to here, okay, to that other corner of the flag. Looks like I'm only going to go back 1 unit and up 1, 2, 3, 4, 5. Back 1 unit and up 5 units. Now, we have a totally different pattern than anything we saw when we did translations. So I just want to see if I can push you to see a pattern. All right. I want you to look at these x's. These are the x values. These are the y values. These are the new x values and the new y values. I just want you to take note of this particular thing. My x's are 0, 3, 5, 7, 5. My y's over here are 0, 3, 5, 7, 5. Interesting. Is it me, or does it seem like all of the x values that I had to begin with are now in the new spot of where the y's are? Interesting. All right, let's continue this idea. I'm going to notice that my y values are a 0, 3, a 5, a 3, and a 1. 0, 3, 5, 3, 1. Okay, let's look right here. 0, 3, 5, 3, 1. 0, 3, 5, 3, 1. Now, granted, it is -3, -5, -3, -1. The numbers are still there, but now they have a new sign as well. So we do need to take note, if we write the description or a pattern in words, there's two things that have switched places, or two things that have happened. Get ahead of myself. It looks like my x's went to the back and became the new y's. It looks like my y's came to the front and became the new x's with a twist. So there's actually two things that happen. So let's write down the first one. The first one is x's and y's switch places. Switched places. Okay. The second thing that happened, okay, when the 3 came to the front and the 7 came to the back, well, I would have had my 7 in the back and my 3 in the front. That would have been the only thing happened if I just switched them. But then the first one went opposite of what I see. So it actually changed to -3, 7. So that's my second one. The new x's, or the first ones, in parentheses, they go opposite. And I want to say opposite because I don't want to really say negative. Yes, that is technically a negative sign in the front, but all of them won't necessarily become negative. This one was positive to begin with and switched to negative. So it went opposite of what it was. Now, we need to write a function rule, and hopefully in the last time you remember seeing these are your x's and y's that you begin with. So we're going to use that to write our function rule for this transformation. All right, we already said the x's and y's switch places. So that's like the y's go to the front, so the y's are going to be in the first spot, and the x's go to the back, so x's are in the second place. So they're switching spots. And then the x's, the new x's, which is the old y's, those are going to go opposite. Yes, Miss Jessup did put a negative sign there, so make sure you put that in there. But I want you to think of that as opposite. So we're actually going to say opposite of y, comma, same x. Opposite of y, comma, same x. Okay? So that's our rule. That's our pattern. This is the big key thing that you're going to see again and again and again. It's called our function rule. We have to understand how to write it and then how to use it. All right, let's go on to the second page. Down below where we just investigated the 90 degree, you see three small graphs that have some dots on them. So what we're going to do is we're going to investigate it. And I've chosen to modify this just a little bit. I'm only going to focus on one dot on each of the graphs. So my first dot is point A. Now I want us to find the coordinates of regular point A. So I'm going to say -1, -2, -3, -4, -5 down 1. So -5 down 1. Left and down is -5, 1. Now I want to rotate this point 90 degrees counterclockwise. And when I do that, I'm going to keep in mind that this is my function rule. Remember, the y's come to the front, the x's go to the back, and then the first one goes opposite. Okay, so that's my function rule. I'm going to practice the rule on this new point. So I want to locate it. So what's going to happen is I'm going to move the -1 to the front. So -1 goes to the front. -5 is going to go to the back. And then we have to remember the first one goes opposite. Opposite of -1 becomes +1. So I've just completed the first rule, or trying to apply the rule to find A prime. So I'm going to go to my graph and I'm going to say, okay, go over 1, down 1, 2, 3, 4, 5. Right here should be the new point A prime. That means that this point was rotated 90 degrees to the left counterclockwise. And if that's a little bit tricky to tell, the easiest way to do, the easiest thing I recommend doing, is let's connect that point A back to the origin, and let's connect A prime back to the origin, because that's our reference. That's where we hold our finger, and then we scoot it around. That angle right there should be a 90-degree angle. So we have truly changed this to and done a 90-degree counterclockwise rotation on it. We've located it from what started off actually in quadrant number what? 3, and we've rotated it over here to quadrant what? 4. So we've done a 90-degree counterclockwise rotation on one single point. All right, let's repeat with point B. Do the same thing. We're practicing using the rule because it's a different rule than any rule we did yesterday. All right, point B. First thing I want to do is from the center, I'm going to go left 1, left 2, down 1, 2, 3, 4, 5. So left 2 and down 5 is -2, -5. All right, now I want to locate the coordinates of B prime. Where would the new point B prime be located? Because that's the old point B. Okay, it should rotate somewhere over here. So what I'm going to do is to get B prime is I'm going to move -5 to the front, -2 to the back. Okay, I don't actually change the back one ever again. I never touch it after this. And then the first one goes opposite. So now I'm looking for +5, -2. +5, 1, 2, 3, 4, 5. -2, down 1, down 2. That should be the point B prime. Again, if you connect it back to the origin, it should be a little easier to see that yes, it did rotate 90 degrees counterclockwise. All right, and this one did go from quadrant number 3 to quadrant number 4. It did change quadrants when you go 90 degrees. All right, I'd like to pause the video or ask you try point C. Okay, so we're just going to ask you to go ahead and pause the video, and I'll wait. You're going to try C, write the point of C down, and then write C prime and see if you can locate it. So point C and then point C prime. See if you can locate those 2 points using your rule. Pause the video now. And we're ready to unpause it. All right. Did you successfully change from C to C prime? Hopefully you saw. So you are switching the 2 numbers from X's and Y's, and then your first ones are going opposite. So the new X's are going opposite. That's practicing. And again, we would have actually moved this one from quadrant number 4 to quadrant number 1. That's the first quadrant at the top. So it did go through 90 degrees. All of these rotated 90 degrees. If you draw it back to the origin and you see that angle, it does make it easier to visualize. All right, let's go on to the next one. Okay, this pattern will be totally different from the other one that we just did. This is 180. And because this picture was the best, clearest one I had, I'm just going to ask you kindly to ignore the top left on my picture. I think I actually fixed it on your copy. This would be A prime. This is going to be B prime, C prime, D prime, and E prime. All right. We're going to try to find our coordinates of our points and see a pattern. It is not the same pattern as the last one, but there is a definite pattern. All right, to get to B, 1, 2, 3 up, 1, 2, 3 up. To get to B, I'm going to go back 1, 2, 3, and then I'm going to go down 1, 2, 3. So Back is -3 and down is, oops, sorry, -3 and down is -3. Of course, 0, 0, I forgot to put that one. 0, 0 is at the center of rotation, so 0, 0 doesn't change because it's right there, right at the beginning. How about to get to C? I go over 5 and up 5, so I'm going to go back 5 and down 5. Back 5 and down 5. Next one will tell the tale. Over 7 and up 3 to get to D. Over 7 and up 3 to get to D. Backwards 7 and down 3 to get to D prime. Backwards 7, down 3. Okay. To get to E, I go over 5 and up 1. Here I'm going to go backwards 5 and down 1. Backwards 5 is -1, down -5, and then down 1 is -1. Is there any kind of pattern that you can see? Notice that it's 0, 3, 5, 7, 5, 0, 3, 5, 7, 5. Did the X's, numbers, just the numbers part, did they stay in the same position? Did the X's stay in the front, or did the X's move? I think the X values actually stayed in the front. Now, they did actually change to what? Negative, 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 where this was all positive, 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 positive. So the numbers actually stayed, but the signs changed. Did you see that? All right, let's look at the other column. Here I have 0, 3, 5, 3, 1. In the other column, Y's 0, 3, 5, 3, 1. Now they are -3, -1, -3, -1. Now, what is the pattern? I hope you see the pattern is the X's are going to stay. So, okay, let's write the rule in words. Okay, first of all, no switching. No switching places. The X's and Y's do not switch places. Okay, but both X's and Y's change sign. Okay, if we write the rule in words, this is the original X's and the original Y's. What happens is the X's stay in the front, the Y's stay in the back, but they both go opposite. Okay, so think of that as opposite. All right, so we could say opposite of X, opposite X's, comma, opposite Y's. And that is the pattern for 180. Notice again, you could go 180 degrees to the left, you could go 180 degrees counterclockwise, or you can go 180 degrees, okay, clockwise. It makes no difference. You'll end up in the same place, okay? So it does not have to be specified. You can just simply say rotate 180 degrees. You don't have to say, you don't need to say clockwise or counterclockwise. Of course, it's fine if you do. So you don't need clockwise or counterclockwise. That's the rule for 180. The X's stay in the front, Y's stay in the back, but they both go opposite sides. All right, let's do our last one. This is our last relationship. This is the last one. Again, forgive me that the pictures, we're going to ignore this one, ignore this one. This is going to be B prime, C prime, D prime, and E prime. And again, A prime being right here will not change. All right, this pattern is similar to the 90 degrees. I'll take note of that. It's similar to the 90-degree counterclockwise rotation that we did first today. All right, how do we get to B? Well, to get to B, we go over 3 and up 3. So here we're going to go over 3 and down 3. So over 3, down 3. All right. To get to C, over 5, up 5. Okay, it's 5, 5. So this is going to be over 5 and down 5. Over 5 and down 5. So this is over 5 and down 5. Okay. Now, this will tell the story right here. I will get to D by going over 7 and up 3. Here I'm going to go over 3 and down 7. Over 3 and down 7. Over 3 and down 7. So that kind of helps us see. And the last one, anybody want to predict? Wish I had a class here that could tell me. I would go over 1 and down 5. Over 1 and down 5. All right, what is the pattern? Here is the pattern. Take a look at your Y's. Y's are 0, 3, 5, 3, 1. Now X's are 0, 3, 5, 3, 1. My Y's, okay, my Y's and my X's switch places. What about my 0, 3, 5, 7, 5, 0, 3, 5, 7, 5. But it did go negative 3, negative 5, negative 7, negative 5. So do you see that the X's and Y's switch places? Okay. And the second thing that happened is what? The new Y's, which are the second ones, they go opposite. So we're trying to devise the rules. So our regular X's and our regular Y's change too. Now what do we say? Y's come to the front, X's go to the back, and then the second ones go opposite. Okay? So we would say same Y's, opposite X's. That would be another way to describe it in words. So that is our function rule for 270. All right, to run through these. What will be the new position of a given point after rotating 90 degrees counterclockwise? And again, Miss Jessica's moving things. If I go 90 degrees counterclockwise, that means that I've got to go against the clock back that way. So if I do that and I connect to the center, I should end up being somewhere over here, and that would put me at A. So remember, I got to go 90 degrees backwards the way the clock, opposite the clock. What will be the new position of the given point 180 degrees around the origin? Now what happens is I am here, and if I go 180 degrees around the origin, I should be up here somewhere. So I should be on the direct opposite side of where I started. All right? And checking your answers for the bottom 4. Now these are just some really simple exercises, probably even aren't high school level, but it's just a way to kind of get you thinking. Please take note of this one here. It did not say counterclockwise, it said what? Clockwise. So that means that I had to remember that my object was going to turn how? It was going to turn 90 degrees this way, right? So I had to go from here to here, which made it look more like a D, okay? So I had to make sure I note clockwise or counterclockwise. All right, good deal. This is just, if you would like to pause the video and just take notice, write this down if you want to. This is just a summary of the 3 kinds of rules that we just came up with as we went through each of the different examples. 90 degrees counterclockwise, 180 degree counterclockwise, and also 270 degrees counterclockwise. Now, I will tell you, if we were going 270 degrees counterclockwise, it would be the same as going 90 degrees clockwise. Let me kind of jump back and refresh and show you that. If I was going to try to get to this flag, my purple flag down here, which is this one here I'm going to highlight in yellow, okay? If I was going to this flag from the start point, nobody wants to have to travel extra distance unless there's a particular reason. So someone say, why would I go backwards 90, 180, 270 and to end up in that position when I could just as easily go forward, okay, go forward, boop, and land there. So if I go from here to here, okay, I would actually be going 90 degrees clockwise, and I would end up at the same flag, okay? So whether you go backwards against the clock, okay, or whether you go forwards with the clock, you actually end up with the same spot. So some people would argue, and that's what I was trying to show you, do pay attention to clockwise, do pay attention to counterclockwise. 270 degrees counterclockwise is the same as 90 degrees clockwise. So it's very important to note that. All right. This is one of your verbal descriptions. You had a couple of these to do. So it's exactly the same. It's describing it with verbiage, with a written language. How do you describe it? Here's where you write your rule that usually begins X comma Y. And for these rules for rotations, it's the same rotation rule for every person. When we did translations, now that rule could change from person to person. I could add 5 and I could slide mine 5 units to the right. Someone else could slide theirs 6 units to the right. Someone could slide theirs 12 units to the right. We could go left 5. We could go up. We could go down. So the number could change. It could be variable from person to person. Rotation rules? No, not at all. I want to rotate this one 90 counterclockwise. Well, if I go back and I look at my rules, which is on the preceding page, okay, 90 degrees counterclockwise. Of course, I'm looking at my notes because I'm trying to put this together. It's opposite of Y, same X's at the back. Okay, we switched X's and Y's. All right, my pre-image points are, and we'll do this first one together. This would be point A, point B, point C. Negative 1, 1, positive 2, 4, and positive 4, negative 1. Now what I aim to do is I'm going to use the rule and I'm going to write my range or find my image points. My image points are referred to as a range. My pre-image points are referred to as a domain. So I need to start using that vocabulary in class so that you've heard it and you're more familiar with it. All right, let's just apply the rule. X's go to the front, Y's go to the back. So 1 comes to the front, negative 1 goes to the back, but then the first ones go opposite. Okay, 4 goes to the front, 2 goes to the back, and then the first ones go opposite. Okay, negative 1 goes to the front, 4 goes to the back, okay, and then the first one goes opposite. So now I have my points. Now let's see if we can put these on a graph. All right, we have a graph. So I'm going to start with ABC, and then we will actually do A prime, B prime, and C prime second. Okay, I'm going to start with negative 1, 1. I'll do this one in red. Negative 1 up 1. Okay. Over 2, up 4, 2, 3, 4. That would be B. And C would be 4, negative 1, 1, 2, 3, 4, and then down 1 to get to C. That's the original, oops, sorry, connected the wrong place. That's the original triangle. And now what I want to do is I should go 90 degrees to the left because it's counterclockwise, and I want to see where it ends up. Well, if I did my points right, it should end up, and I'll do this in blue. Okay, I'll erase my arrow. Negative 1, and that would be A prime. Negative 4, 1, 2, 3, 4, positive 2, and that would be B prime. Positive 1 and positive 4, and that would be C prime. Boom, boom, boom. It is hard for me to see it sometimes, but if you connect, right, remember, if you connect back to the origin, I can tell that A and A prime did go 90 degrees. It's kind of tough to tell, but this graph did go over here, and now C is sticking up in the air. B is to the left. So we've done our four representations, our verbal, our algebraic, our table, and then our graph. All right, let's go to your first homework, okay? First thing I want you to do, if you haven't already, is write your rules at the top. I know this is a long video, but if you weren't here, I want you to have a good resource. Y's come to the front, X's go to the back, the first one goes opposite. 180, opposite of X and opposite of Y. For 270 counterclockwise, it's almost the same as 90, Y's come to the front, X's go to the back, but this time the second ones go opposite. Now, we're going to do number 1, and then I'm going to let you guys finish this because you need the practice. I just want to make sure you have a good start. Now, notice this says 90 degrees clockwise. That's CW. I do not have a 270 or a 90 clockwise. This one says counterclockwise, or do I? Ding, 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 ding. So this says same as 290, 90 degrees clockwise. So here's the rule that I'm going to use. Y comma negative X. Okay. So the first thing I need to do is this is for A prime, B prime, C prime. This is for the new ones. What I want to do probably is make note of the original A, the original B, original C, and the original D points. All right, A, good thing I like this graph, -3 and down -3. B is at -1 and down -5. Okay, I went down there. C is located +3 and down -3. And D is located at back 1, down 1, -1, -1. Now, what I want to do is, Miss Jessup's going to use a blue pen to get us started. I'm going to apply the rule for 270, which is the same as 90 clockwise. So what I want to do is, this is the same. Oh, shoot. Picked up the wrong thing. All right, let's fix that. There we go. -3 comes to the front, -3 goes to the back. It seems too easy. But remember, the second one goes opposite. So now it's -3, +3. All right, for B. All right, -5 to the front, -1 to the back. Second one goes opposite. Okay, so that's a positive. It's a +1. Okay. C prime, -3 goes to the front, +3 goes to the back. But then what happens? The second one goes opposite. And D is -1, -1, even though they really don't look different. The second one goes opposite. Now I should have my points. Let's see if we can locate this one. -3, +3, 1, 2, 3. That would be A prime. All right. B is -5, +1, -5, +1. There's B prime. -3, -3 is actually right on top of A, so that's A and C prime at the same time. And then I should have -1, -1, +1. -1, +1. Boom, boom. That would be D prime. Boom, boom. Does it look like this picture went 90 degrees clockwise? Well, if you compare, and it looks like this right here, it went and it went right up there. Yes, it did go 90 degrees clockwise. All right, that's your notes for rotations. You need to finish the homework. You need to show it to Miss Jessup so she can give you credit, and you got to make sure that you're doing what you need to do when you need to get caught up.